Welcome back to the Explainer, Focus Learners. Today, we're diving into literally the ultimate cosmic mystery. We're going to push way past the boundaries of what we thought we knew and investigate exactly what existed before the absolute beginning of time. If you've ever found yourself staring up at the night sky and wondering, what on earth was there before all of this? Well, you are in the exact right place.
For almost a century, our standard textbook cosmology, the stuff heavily anchored by Einstein's general relativity, gave us a very firm starting line. According to that model, our universe began roughly 13.8 billion years ago, and under this strict Einsteinian view, space and time are woven together into a single fabric. So the creation of matter and the expansion of space was quite literally the creation of time itself.
Okay, let's dive into this. We're going to violently shrink that massive timeline down to a super specific anchor point, exactly 60 minutes before the cosmic clock started ticking. Just one single hour before Genesis.
So, what actually happened 60 minutes before the Big Bang? Now, classic physics would tell you that question is basically a logical fallacy. You can't have 60 minutes before time itself existed, right? Well, modern theoretical physics totally disagrees. Think of this explainer as a three-act cosmic crime scene investigation into what we call the illusion of the beginning.
The whole conflict really starts with this idea of a singularity. Under general relativity, the universe compresses backward into a tiny point of infinite density, infinite temperature, and zero volume. But here's the secret. Infinite density is actually physically impossible in the real world. Physicists increasingly view this singularity not as a real physical event, but as a mathematical glitch. It's like a glaring warning sign that our equations are breaking down because they're missing a completely crucial ingredient, quantum mechanics. Because when an entire universe is compressed smaller than a subatomic particle, quantum forces absolutely have to dominate. So to figure out what our cosmic clock read at T-minus 60 minutes, we have to look at the three leading rival theories attempting to fix this glitch.
Act 1, the Big Bounce. This first theoretical framework tries to smash quantum mechanics and gravity together. In this model, space isn't just some smooth, empty, continuous fabric. It's actually made of a network of microscopic, indivisible intersections. Basically, space has atoms. And that brings us to the Planck volume. We're talking about an unbelievably tiny number, roughly 10 to the power of negative 105 cubic meters. In loop quantum cosmology, this is the absolute minimum allowable volume in the universe. It acts as a hard physical limit. You simply cannot compress space any smaller than this.
Now, imagine a previous universe collapsing inward. As it hits that critical threshold, the Planck density limit, it acts like a tightly wound quantum spring. Right at that exact moment, gravity suddenly flips. It instantly transforms from this attractive pulling force into a violently repulsive force, blasting everything outward in a massive bounce.
So what does this cyclical model mean for our specific anchor point? Well, at exactly T-minus 60 minutes, space was definitely not empty. Actually, an entire pre-existing universe was going through a catastrophic big crunch. Gravity had completely overcome all expansion forces, and all the galaxies, stars, and black holes from a previous cosmic cycle were being ripped apart and squished into this shrinking, ultra-dense plasma soup. It's kind of like a dying star collapsing into a supernova, but magnified to the scale of the entire cosmos. Moving on to Act 2, the multiverse and eternal inflation. Developed by physicists like Alan Guth and Andre Linde, this theory gives us a wildly different picture of our T-minus 60-minute mark. To wrap our heads around this, let's use a visceral metaphor, the champagne glass analogy. Imagine a chaotic, high-energy background called the inflaton field. It's like a boiling pot of water or the bubbling bottom of a champagne glass, where quantum fluctuations are constantly popping off. In this model, known as eternal inflation, inflation didn't just happen once to our universe, it's happening forever, everywhere, across this grander hyperspace.
So 60 minutes before our Big Bang, our specific universe simply didn't exist. Instead, an infinite, glowing, hyperdimensional ocean of hyperspace was expanding exponentially, way, way faster than light, packed with unimaginable vacuum energy. Our universe was actually born right at T-minus 0, when a tiny, localized patch of this hyperspace experienced a sudden decay in its energy field. Inflation slowed down right in that pocket, and all that excess vacuum energy dumped down into superheated standard matter and radiation. That tiny pinched-off bubble? Yeah, that's us. And that brings us to Act 3, Conformal Cyclic Cosmology, or CCC for short. Proposed by Nobel laureate Sir Roger Penrose, this theory completely bypasses the headache of needing a quantum gravity theory, relying purely on geometric scaling.
So how does CCC deal with the end of time? Well, the crucial point is 60 minutes before our Big Bang, there is no dense crunch and there is no chaotic multiverse. It's just the absolute frozen end of a previous universe that lived for trillions of years. All the stars are dead, even the supermassive black holes have dissolved. The universe contains literally nothing but massless particles like drifting photons. And here's the kicker. Because there is no mass, there are no clocks or rulers to measure time or scale. To a universe with no scale, the math does something absolutely incredible. Infinitely large and empty recalculates to become mathematically identical to infinitely small and dense. And this brilliantly illustrates how the geometry of that infinitely large, dead future smoothly fits right into the hyper-dense geometric origin point of the next universe. The old universe doesn't physically crunch back down, it simply fades and seamlessly transforms right into the spark of the next aeon. It's literally like a cosmic snake eating its own tail. Let's move on and see how this builds into a bigger picture. Section 4. Comparing cosmological clocks. We've looked at 3 wildly different cosmic crime scenes, and now it's time to put them side by side. Let's walk through this comparative dashboard together. If we had a synchronized cosmic clock exactly 1 hour before our universe was born, what would it actually record? Well, under standard general relativity, the clock is totally invalid. Time doesn't exist, and there's absolute nothingness. Under the Big Bounce, the clock is ticking backward into a shrinking history, measuring a hypercompressed plasma of a dying universe triggered by quantum repulsion. Under eternal inflation, the clock ticks continuously across hyperspace, measuring a super-expanding vacuum field that triggers a universe through localized decay. And under CCC, the clock is entirely meaningless due to a total lack of mass, so it's measuring a trillions of years old cold void that triggers a new Big Bang through a conformal scale breakdown. 1 single hour, 4 vastly different realities. But why does all this mind-bending theory matter to us today? Let's look for the cosmic echo.
You see, modern astrophysicists aren't just sitting at whiteboards guessing about this stuff. They're actively hunting for clues right now. They're looking for actual physical scars left behind from whatever existed 60 minutes before our universe was born. By utilizing revolutionary tools like the James Webb Space Telescope and future gravitational wave detectors, scientists are searching the deepest reaches of the cosmic microwave background for bruises or ripples. They are literally looking for the physical echoes of a previous universe's collapse, the collision of multiverse bubbles, or the dying bursts of ancient black holes from an eon before our own.
The entire illusion of a singular beginning has been shattered, whether we're a bounce, a bubble, or a sequential aeon. The boundaries of reality are far, far grander than we ever imagined. Which leaves us with this final, mind-expanding thought. If our universe is really just one cosmic echo in an infinite chain of creation, what kind of bruise will we leave behind for the next universe? Keep questioning, keep learning, and I'll catch you in the next explainer.